So this next presentation, the very first presentation of the day, anyone who's in the gaming industry will probably be familiar with the fact that back around Game Developers Conference timeframe, we acquired a company called Scaleform. And it was something that happened kind of so quickly and suddenly at the time that we still had two separate booths at GDC that we were running back and forth between. Well, here at SIGGRAPH, we are now a fully integrated group, and our first presentation is going to be around Scaleform, and I have Nate over here on the side who's going to take us through what exactly Scaleform is and all the technology that they work with. So, Nate, take it away.
All right. Good morning, everybody. I'm Nate Mitchell. I'm a software engineer here at Autodesk. I'm on the Scaleform team. And I'm going to be providing everyone with a short overview of Scaleform. We're the leading UI middleware solution in the video games industry. I'm going to start with a high-level overview of the Scaleform technology, and then I'll dive in to some of the latest tools and the features in the Scaleform 4.0 SDK. For those of you that are more interested in a detailed explanation of the new renderer in Scaleform 4.0 and the technology behind that, Michael Antonoff, Scaleform's chief architect, will be presenting tomorrow at 12:45, booth 801. He's right there in the audience. And his talk is entitled Multi-Threaded 2D Renderer Design. So with that, let's get started. So Scaleform, as I mentioned, is the leading user interface middleware solution for the video game industry. Scaleform is an Adobe Flash-based solution. And at the core, Scaleform is a hardware-accelerated vector graphics engine with Edge AA and tessellation technology that supports the playback of Adobe Flash content. What this means for video game developers is that they can create their content, their UIs, in the Adobe Flash pipeline, and then bring that directly into their game engine. If you're familiar with the standard Adobe Flash player, you know that it's a software-based renderer. So what we do is we take the 2D Flash content and tessellate that into triangles, which we then send to the GPU to be rendered. Most commonly, Scaleform is used for interface overlays like game menus and heads-up displays. But you can also render Scaleform content to textures within the game world to create a more interactive and immersive environment. So I'm going to try and show you a short demonstration by BlackRock Disney. This is some of the menu interface for their game Split Second. There we go. So what you're looking at here is their main menu done using Scaleform. You can see that they're using 3D objects and they're rendering Flash on top of them. You can see some of it is just overlaid on the screen at the bottom, top right. But you can also see how they use 3D to incorporate Scaleform into their game. The heads-up display on the bottom of the car, that's Scaleform in action. So a few key features of Scaleform for those of you unfamiliar with the technology. So Scaleform allows developers to use high-quality, animated, anti-alias vector graphics, as well as bitmap images to create their UIs. This gives developers and artists a lot of freedom and flexibility in how they choose to create the content. Scaleform includes a dynamic font system that allows for both vector and bitmap-based fonts to be embedded in the Swift file or loaded at runtime. These fonts can be easily shared across Flash files to reduce the overall memory footprint. Scaleform also supports rich text, which allows developers to use multiple fonts in the same text field, or embedding images within text fields, or using HTML text. Scaleform also supports masks for arbitrary shape clipping and shape animations, and blend modes like add and multiply, as well as filter effects like glow, drop shadow, and blur. And all of these can be applied to text or shapes in the Scaleform content. So one of the neat things that Scaleform also provides is extensions to create 3D UIs, like you see here in this screenshot. And these extensions allow you to take Flash elements and rotate them in 3D space. So these extensions can be used to easily create pretty innovative stereoscopic interfaces, something Crytek executed very well in Crysis 2 using Scaleform. but they also let you do 3D interfaces like you see in the screenshot here. This is actually a demo we did in Unreal Engine using Scaleform 3. And it's a bit Dead Space inspired if you've ever played the Dead Space series. And the idea here is that rather than render the interface as an overlay, we're actually rendering it within the game world and then creating the illusion that the character is interacting with the 3D interface in the game world by adding depth to it. Scaleform really lets you develop experiences like this rapidly, and there's no limit to what your teams can do with Scaleform technology. And we'll see if I can get a little demo of that running. Maybe, maybe not.
It's running.
Oh, it is running. Oh, I'm sorry. Well, I'm actually going to pull it up in, hang on. I'm going to pull it up in Windows Media so I can skip around.
We can't see it, though, if it's on your screen.
Okay, let's see.
Because you're in presenter mode.
Thank you, thank you. So this is a UI that we put together for Unreal Engine. You can see Scaleform 3DI in action as images move back and forth with Z depth. This is actually included in the UDK and the Unreal Engine, so developers can take a look at the code behind it. And let's see if I can skip forward once again to get to some of the in-game. So here you can see Scaleform being used for the HUD, the mini-map. And here is that 3D interface we just talked about. This is an inventory screen. And you can see the character looking at it and interacting with it in 3D space. So it really lets you create a more immersive experience with your game. Finally, we have Scaleform's 4.0 multi-threaded architecture. So 4.0 was architected from the ground up to be fully multi-threaded, which makes it much easier to integrate with today's latest game engines. So here's a short peek at the Scaleform core. I'm going to provide a quick high-level overview of some of the features. So Scaleform provides a Flash runtime and a loader. The Flash runtime handles the playback of the SWF, timeline-based animations. It maintains the Flash movie state and the display tree. And it also communicates with the ActionScript virtual machines. The loader itself handles loading the SWFs, which are compiled Adobe Flash files. And the loader supports background progressive loading out of the box. If you're unfamiliar with Flash, ActionScript is Flash's proprietary scripting language. And we provide virtual machines for both ActionScript 3 and ActionScript 2. And these virtual machines process and play back the bytecode within a published Flash file. It's also important to note that Scaleform is cross-platform. We have OpenGL, D3D9, Wii, GCM renderers. And we also provide executables for Win32, OS X, Linux, iOS, and Android. So along with the core product, Scaleform also includes a video solution that allows you to embed high-definition videos in your Flash content or play them back full screen. Scaleform Video uses the CRI codec, which provides excellent compression and support for multi-track 5.1 audio, subtitles, and cues. There's also the Scaleform Input Method Editor, or IME for short. Scaleform IME enables a game to support multiple language profiles and multi-language chat by adding Asian language inputs to the game. It supports many of the most popular Asian IMEs. This is the type of thing you would use when developing a game like StarCraft 2, and can be fully skinned to match the UI of your game. Scaleform also ships out of the box with full audio support. By default, Scaleform uses Fmod. But this can easily be replaced by any audio backend of your choosing. And the SDK actually provides sample code for integrating audio playback through WIs. So a little bit about the Scaleform workflow. How does actual art assets make it into the game engine? So first, the UI artist or designer creates the assets that'll be used for the UI in tools they're familiar with, like Photoshop, Illustrator, if they're doing graphics, or video. They might use Autodesk Infernal, Final Cut Pro, that sort of thing. Next, those assets are brought together, animated, and made interactive using Adobe Flash Studio. You can add interactivity using C++ or ActionScript. You can actually use any scripting language that your game may use because we supply native APIs for manipulating Flash elements at runtime using native code. I'll talk a little bit more about that later. So developers designing their UIs in Flash Studio, they can preview the content outside of the game engine using Scaleform's FX player, which will play the content back exactly as you'd see it in the game. And this allows them to iterate more quickly and effectively within the game development pipeline because they don't have to re-import all their content and rebuild the game to see their changes. Artists and UI developers can also profile performance and rendering of the content using Scaleform AMP, which is our custom profiling tool, which I will give you a short demonstration of here in just a minute. So just to give you an idea of who's using Scaleform and our track record, here are a few of the top developers, studios, and publishers that have used Scaleform in their games and are licensing Scaleform for upcoming games. We've been using over 800 titles, and that number continues to grow. Just to highlight a few recent titles you guys may have heard of, we have Crysis 2 by Crytek, Mass Effect 2 by BioWare, StarCraft 2 by Blizzard, Dragon Age 2 by BioWare, Mortal Kombat by NetherRealm Studios, and Mod Nation Racers by United Front Games. And these games do a really excellent job of demonstrating the versatility and the flexibility of Scaleform as a UI development solution. You have games that are cross-platform here, like Dragon Age 2 and Crysis, that are console and PC games. Crysis is a first-person shooter, Dragon Age 2, a complicated PC RPG. But you also have things like Fighters, Mortal Kombat, Mod Nation Racers is obviously a racing game. And StarCraft, you have a complex PC RTS, along with a portal to Battle.net, all done using Scaleform. So as you can imagine, Scaleform is supported across all major platforms, Xbox 360, PS3, Wii, PC, Mac, Linux. And we also have multi-controller extensions that allow developers to easily create interfaces that support 2 or more simultaneous users on the same console. This is especially important if you're developing for a system like the Wii, where you have multiple mice and buttons interacting maybe with one menu. With Scaleform 4.0, we launched on mobile devices, so we fully support all the iOS devices, iPhone, iPad, iPod. We also support Android, and of course Nintendo 3DS and Sony NGP and PSP. Multi-touch. We support the Flash 10.1 multi-touch API, which means that you can actually code all your multi-touch and gesture events in ActionScript, or native code if you prefer, and bring that across platforms, and it'll work the same way. We also have audio stereoscopic support out of the box for platforms like the Nintendo 3DS, which allow you to create 3D user interfaces like we saw before easily. So we're integrated with just about every major engine. Just a few here are Big World, CryEngine 3, Hero Engine, Fire Engine, and Trinergy. Most of these engines provide integrations with Scaleform that are actually handled by the engine developers. And in 2010, we partnered with Epic Games to make Scaleform the UI solution for Unreal Engine 3 and the Unreal Development Kit. And that means that all Unreal licensees actually receive a license of Scaleform for their game. Finally, Scaleform uses a plugin architecture for all the important functionality like file I/O, image loading creation, translation, fonts, the HAL renderer. So this means that this can be all these inputs can be easily customized for your proprietary game engine. So along with the SDK, we provide some tools that make developing Scaleform content and optimizing Scaleform content that much easier. Probably the most important of those tools is Scaleform AMP, the Scaleform analyzer for memory and performance. So AMP allows you to remotely profile content that's running locally or on a network device And it can be running in the standalone GFX player on an artist's local machine, for instance, or in an instance of Scaleform running in the game. So you might have Unreal Engine running on the 360 over the network. You can connect directly to it and profile the content there. It can connect to any instance of Scaleform running on the network, and it monitors things like CPU usage, graphics rendering, and memory consumption. We designed AMP specifically for artists and UI developers to profile their Flash content, and it includes all sorts of visual tools like real-time graphs, per-frame stats, per-frame action script timings that really allow all of the developers to figure out, where they can improve their content. If we have time, I'll show a short demonstration of AMP at the end of the presentation. We also include Click, which is the component lightweight interface kit. Click is basically a set of ActionScript 2 and ActionScript 3 interface elements, libraries, and workflow enhancement tools that help you develop your Scaleform content that much faster. The Click widgets are specifically designed for game development. These are widgets like buttons, checkboxes, lists, and that sort of thing. If you're familiar with Flash, you may know that Flash has an out-of-the-box component set. Unfortunately, these components are a bit slow. They're designed for a web experience, and they're difficult to skin. So we set out to develop Click, which is specifically designed for game UI, and it's highly optimized, lightweight, very extendable, so that users can easily create their own components, and easily skinnable for your artist. We also include our UI kits. And our UI kits are basically best practice samples that can be taken and easily added to your game, skinned and customized to get you up and running with various Scaleform use cases quickly. We have the HUD kit, which is a HUD FPS first-person shooter heads-up display that runs under a half a millisecond. We have the menu kit, which is a full-blown console and PC game menu that starts with a splash screen, dynamically loads content, plays an introduction movie, has a start game option screen, that sort of thing, and then actually brings you into a game. And then we have the MMO kit, which I also hopefully can show you here in just a minute. And the MMO kit is the basics of an MMO UI. With things like inventory, chat, action bars, that sort of thing. And you can take these kits, you can tear them apart, you can look at them, they're full source code, fully documented. And they really serve as an excellent learning tool for developers. And it's all production level code developed by us, optimized by us for you guys. So now I'm going to jump into what's new in Scaleform 4.0. Performance has always been one of our top priorities, and for 4.0, we spent the last 2 years developing an entirely new multi-threaded intelligent renderer. This allows us to desynchronize the advanced and display threads, which will give you about a 2 to 10 times performance gain, depending on your engine and your implementation. I'm not going to go deep into the rendering architecture here, but for those of you that are interested, again, Michael Antonov, our chief architect, is going to be presenting tomorrow at 12:45, booth 801, on multi-threaded 2D render design, and he will happily answer all the questions about Scaleform's vector graphics renderer. So a little bit about some of the features of the renderer. We support intelligent batching. This means that the renderer actually batches groups of shapes with like fills and geometry into a single draw call. So you take something like this, an MMO UI kind of sample. This running in Scaleform 3 has 566 draw calls and about takes between 5 and 20 milliseconds to render. So what you see here is the same file running in Scaleform 4.0. This has a view enabled that shows us what shapes are being grouped together into single draw calls. In this picture, shapes with the same color are actually being grouped into a single draw call as if they were on a single texture sheet. And this is all happening automatically. None of this has to be set up by artist or programmer, although it can be, content can be developed with all these optimizations in mind. So the performance impact of Scaleform 4.0 on the same content, we go from 566 draw calls to about 120 draw calls. and from rendering time of about 5 to 20 milliseconds, all the way down to somewhere between a half a millisecond and 2 milliseconds. So you can really see the impact of on performance the 4.0 renderer has. This really allows your artists to do more, be more creative, with a far reduced performance impact. Developers can, of course, further optimize their content by creating their own image atlases to further reduce the draw calls. This, as always, can be achieved by hand using custom tools, or we provide our own tool, GFX Export, which will actually export all the images in a Flash file into a packed texture that can be exported as DDS, TGA, whatever is good for your engine, and then loaded at runtime. A little bit more about the renderer. So for any given frame, you're going to have a scene graph, which is basically a list of all the elements in the display tree. In previous versions of Scaleform, Scaleform would walk the display tree every tick and actually send the full display tree information over to the GPU to be rendered. This is slow, as you can imagine. So in Scaleform 4.0, the render actually walks the tree once, caches it to the CPU, and then sends it to the GPU to be rendered. From then on, rather than sending the full display tree every tick, we monitor changes in the display tree. And when a change occurs, we send that change and that change only over to be rendered. This will give you about a 20% performance improvement on existing content, as well as new content. A few quick performance metrics. These are all based on PC data. You're going to see probably a display improvement of about 4 to 5 times faster on the CPU, about 2 times faster on the GPU, and anywhere from a 50% to a 75, well, a 2x performance reduction in draw primitives. For an FPS HUD or the MMO like you saw before, let's talk about the HUD kit. Before, in Scaleform 3, we're talking somewhere between 1 and 5 milliseconds to render the UI, and about 100 draw primitives. In Scaleform 4, the same content, completely unchanged, ActionScript 2, just in Scaleform 4.0, runs well under half a millisecond, which is really crucial for HUDs, and about 30 draw primitives. So you can really see, again, the difference. The other big thing in Scaleform 4.0 is, of course, Flash 10.1 and AS3 support. This is something that we wanted to do for a long time. We finally had the chance. So ActionScript 3 is about an order of magnitude faster than AS2. It's a better language for development. It's strongly typed. It's just a little bit more programmer friendly, a little less loose around the edges. And we absolutely support all of Flash 10.1 features like multi-touch, like I mentioned before. Now, if you're currently working in an ActionScript 2 code base with Scaleform, but you want to move to Scaleform 4.0, you don't have to worry. You don't need to convert all your content to AS3. Scaleform 4.0 has full legacy support for all ActionScript 2 content. So if you're working with an enormous existing code base, you can actually get most of the performance gains from Scaleform 4.0 just by taking that content and bringing it into 4.0, integrating 4.0 into your engine. And for the engineers out there, the ActionScript 2 and ActionScript 3 VMs are optional. They can either be linked in or not linked in. You can compile them out with one short line. So the Scaleform advantage, to kind of wrap up here. You're going to get a streamlined workflow and rapid iteration. Creating Flash content is really easy. You're using familiar tools and a pipeline that really empowers artists and designers to do more. You're going to get the fastest multi-threaded vector graphics renderer on the market as far as we know. Scaleform is very easily integrated into your proprietary engine. And if you're using an engine developed by one of our partners, there's probably already a Scaleform integration readily available for you. The Scaleform SDK comes with all the great documentation and AAA localized support, so you can ask questions directly of our engineering team. And the documentation includes plenty of samples, kits, videos, and tutorials. And these are actually all localized in Japanese, Chinese, and Korean for our Asian developers as well. The SDK also includes tools I've talked about here, like Scaleform AMP and GFX Export. And the UI kits great references, great samples for best practices, content creation, learning how to develop Scaleform UIs, how to optimize Scaleform UIs, and how to just take content, Flash content, and hook it up to your game engine to efficiently communicate. With Scaleform, you know you're going to be using a mature code base. We're in a 4.0 release, and like I mentioned, we have over 800 titles that have licensed us. And this list includes some of the biggest games of the last decade. We've got plenty of AAA developers that keep coming back. And finally, developers can license the full source code to our SDK for more complex customizations if they so desire. So that about wraps up my time. Thank you all for listening. I would be happy to show product demos of Scaleform AMP, any of the kits, the MMO kit, the HUD kit, the menu kit. If you want to just come stop by, I'll be around all week. Again, my name's Nate. If you have any questions about Scaleform or anything else, just feel free to stop by the booth and grab me. I'd be happy to talk with you. Thank you again.
Thanks a lot, Nate.